Welcome to the rod cutting algorithm tutorial. Today we will explore how to solve the rod cutting problem using dynamic programming, a method that can significantly optimize the solution. This tutorial is presented by Napat Decha and Apiwit Chantakhad. Rod cutting algorithms have top-down dynamic programming approach with the memorization, bottom-up dynamic programming approach with tabulation. In top-down dynamic or memorization programming, given a lot of length n and a list of prices that correspond to the certain price of lots of length I from 1 to n. The objective is to find the maximum revenue by cutting up the rod and selling the pieces. To solving this problem would be to try every possible way to cut the rod and calculate the maximum revenue, means R. And when you didn't choose dynamic programming, it will become inefficient for larger rod of length. For rod of length n, we could make 2 to the power of n minus 1 cuts, which is expensive. Memorize rod cutting algorithm. For memorization, we initialize the code to initialize the table by the first algorithm here. Ri equal to negative infinity means we initialize I to all unobserved elements in Ri. Then the main program starts working by return this recursive function. And then second algorithm, inputs are in P and R. In the first, if we check the solution are in the table, if solutions are in the table, we just return the solution, or otherwise check it Q equal to negative of infinity means initialize the negative last number to revenue, and in the Q max, it will cut all the possibles from 1, 2, 3, and so on, and then plus by the recursive cost all the rod cut again and maintain it in the table. Tabulation, on the other hand, is a bottom-up approach where we solve all possible subproblems first and use this result to build up the solution to the original problem. This involves filling up a table based on the recurrence relation, which allows us to systematically compute the solution by solving subproblems in a structured manner. Idea of lot cutting algorithm. Problem description: given a lot of length n units and the price of all pieces smaller than n, find the most profitable way of cutting the rod. Let's define Ci as the price of the optimal cut of a lot up until length I. Let Vk be the price of the cut at length k. How to develop a solution? We define the smallest problem first and store their solutions. We increase the lot length and try all the cuts for the size of lot, taking the most profitable one. We store the optimal solution for this size piece and build solutions to larger pieces from them in some sort of data structure. I will show you how to use memorization to solve problem. Lot cutting with length 8. So I will give you the table of length 8 and the price of them. And we will use the Ci equal to max of the Vk, it means the original value plus by C of I minus by its original volume. C1 equal to max, V1 equal to 1 because the original value of 1 is equal to 1. C2, V1 plus C1 is equal to 1 plus 1 equal to 2, and V2 is equal to 5. So you will see that V2 is more than the V1 plus by C1, so the maximum of it is be 5. And C3 V1 plus C2 equal to 1 plus 5 equal to 6. And V3 equal to 8. So the 8 is more than 6. So the C3 is equal to 8. And when we have the optimal solution, we put it in the table, and then we use this formula along so on until it length 8 C8 equal to max of V6 equal to C2 is equal to 17 plus 5 is 22. So say the optimal way to cut is C8 equal to V2 plus by C6 equal to 22.
Let's get into the optimized solution. The lot cutting problem is a classic optimization problem where the goal is to determine the maximum revenue obtainable by cutting up a lot and selling the pieces. And to solve the optimization problem using dynamic programming, we must first characterize the structure of an optimal solution. Specifically, we must prove that we can create an optimal solution to a problem using optimal solutions to a sub-problems. Then we can store all the optimal solutions in an array and compute later elements in the array from area elements in the array. Okay. We can't really use dynamic programming if the optimal solution to a problem might not require sub-problem solutions to be optimal. This often happens when the sub-problems are not independent of each other. So next is sub-problem statements. Here we have a lot of length n and array of prices p, where pi is the price of a lot of length I plus 1. Determine the maximum revenue Rn obtainable by cutting up the lot and selling the pieces. Here is the goal of this problem to maximize the revenue obtainable by cutting up a lot of length n and selling the pieces. The input of array is a array prices where pi is the price of a lot of length I plus 1, and output is maximum revenue that we obtain. Okay, so let's get into the code implementation. The first one is the revenue array. As you can see, this one is initialized to 0. This array will store the maximum revenue obtainable of each length from 0 to n. The second one is the nested loop. As you can see, for each lot length j from I to n, is the maximum revenue is calculated by considering all possible first cuts. Then for the inner loops, it tries for every possible length I for the first piece that computes the revenue for that cut, and keep track of the maximum revenue. And the last one is the result. After filling up the revenue array, the maximum revenue of lot of length n is stored in revenue n. And as you can see, there's the example uses, we have array of price and the length. If we use the upper part of the code, we can easily print the maximum revenue. Okay, let's get into the time complexity. Time complexity of lot cutting is O(n) squared, because there are two nested loops, as you can see, each running up to n. Okay, next one is space complexity. Space complexity is O(n) due to the revenue array are used for sorting intermediate results. Okay, and how do we apply lot cutting to our real world? The lot cutting algorithm can be applied to a variety of real world scenarios where a resource can be divided into a smaller parts to maximize profit or utility. First one is steel manufacturing. In steel manufacturing, a large steel beams or a lot need to be cut into a smaller lengths to meet customer orders. The goal is to cut the beams in such a way that maximize revenue, given that different lengths have different demand and prices. Second one is cable industry. In the cable industry, long cables are often cut in shorter lengths to be sold to customer. Each length may have different price depending on demand. Third one is woodworking. Often purchase large planks of wood and need to cut them into pieces of various sizes for different projects. Each size can have different value. And the last one is paper industry. In paper industry, a large loads of paper are cut into smaller sheets or rolls of different sizes. The goal is to maximize the profits from selling these smaller sheets of rolls. Thank you very much.